3.1 Statements and Logical Connectives. So chapter 3 is completely new. Anything you've learned or we're going to learn in this chapter, it's going to be new for all of us. If you're into coding or anything like that, or if you like computer science, you might know a little bit of what we're talking about, but for the most part, this is really, really, really new. So if at first you don't understand it, it's totally fine. This happens every semester where some of us will be like, yeah, I get it. And then a lot of us will be like, I have no idea what you are doing. That's okay, because at the end of chapter 3, you're going to be like, oh my gosh, like I totally get this. This is a super duper easy chapter. I got this. And if not, that's okay too. This is completely new, so just take it slowly. Take it one example at a time. Alright, so some history. The Greeks are Aristotelian logic. The ancient Greeks were the first people to look at the way humans think and draw conclusions. Aristotle, who lived between 384 and 322, is called the father of logic. This logic has been taught and studied for more than 2,000 years. We still follow Aristotle and his teachings. A lot of what we do is based on his philosophy. So if that's ever interesting, look him up, Aristotle philosophy, and you should take a philosophy class in college. Philosophy is a wonderful class. It teaches you about how to think, and I know it's like, well, I know how to think. Nah, not really. A lot of us don't know how to really think logically and think for ourselves. And it can be really important to take that class, especially now in college. So if you have the time and are interested, take a philosophy class. You will not regret it. Anyways, so mathematicians, how did they talk about logic? Why is math all about logic? So Leibniz was believed that all mathematical and scientific concepts could be derived from logic. He was the first to seriously study symbolic logic. In this type of logic, symbols, usually letters, represent written statements. So Leibniz is actually the other inventor of calculus. A lot of people say Newton is the inventor. I would say Leibniz is the inventor, and Newton stole a lot of his ideas from Leibniz. But anyways, I digress. So, you might know this name, George Boole. He's the founder of symbolic logic because he has such an impressive work in this area. You might know that name from history class, you might not know. But there's someone you definitely do know, Lewis Carroll. So Lewis Carroll, I don't know if you know this, but his books are really based on logic. Alice in Wonderland, the book, the original book, it's all based on a game of chess. It's all logic. So it's actually super fascinating. After you take this, to do this chapter, if you're interested in reading and you like to compare, contrast things, and if you read Alice in Wonderland, you should reread it, or do read it if you haven't, and then see how it is it's all based on logic. Alright, that's enough of that. Let's get to it. Logic and the English language. So, logic is a way for us to talk about sentences and structures and statements and break them down into simple things that are similar to numbers. Because we know 1 plus 1 is 2. That's very simple. We put two things together. So let's see how we can do that with statements. So connectives, just like in English class, those are words such as and, or, if then, if and only if, but, however, nonetheless, all of those are connectives. Inclusive or, one or the other of the given events can happen, but not both. Inclusive or, one or the other events, one of the other or both events of the given event can happen. Don't worry about exclusive or inclusive ors, because we don't talk about that in this class. We keep it very straightforward. Statements. A statement is a sentence that can be judged either true or false. So the sky is blue. That's a statement. True. Because you can't be like, well, it's not blue. No, the sky is blue. Just because it's cloudy doesn't mean the sky's not blue. It's just clouds over us, but the sky is blue, right? Or another simple statement, asphalt is black, right? We drive on black asphalt. It's black. So a simple statement, it's only one idea. So the sky is blue, asphalt is black. I can even give you a false statement. The ocean is purple. No, it's not. It's a various shades of blue because of the sky. A compound statement is a sentence that combines two or more simple statements that can be assigned a truth value. So the sky is blue and grass is green. Compound statements, because I'm talking about two things. I'm talking about the clouds, I'm talking about the grass, and I can assign a truth value to that. I can also say, I drive a car, the car is blue, right? I'm driving a car, true or false? Car is blue, true or false? I can assign values to those. Negation of statement. Negation of statement, you change the statement to its opposite meaning. The negation of a false is a true, and the negation of a true is a false. So if I said the sky is blue, I can negate that by saying the sky is not blue. Quantifiers. Quantifiers are words such as all, none, or no, some, etc. So like things you can put a value. Like I have some books. I have some of these things. I have none. I have all. Those are all quantifiers. So it's kind of like a word meaning how many do you have. So form of a statement and form of negation, you can say all are. To say the opposite of that, you say some are not. None are, or some are, and then vice versa. So we're going to write each statement as a negation. I'm going to change my screen to black now that the definitions are over. There we go. All right, so let's write the negation of some books are novels. So let's figure out like what is it actually saying by some books are novels. So let's break down the word some. So some, if you say some of something, that means at least one thing. So at least one. So if I say some of this class is wearing shoes, because we can wear sandals, we could say, to say some, we say at least one person. Because if I say some, it's an umbrella term, meaning at least one. So what we're actually saying here is at least one book is a novel. You can change it to be grammatically correct. So if I'm saying at least one book is a novel, if I'm saying at least one person in this class is wearing shoes, to negate that, to say the opposite of at least one, I have to say no one. So no books are novels. So to negate at least one, to say the opposite of at least one person, you have to say nobody. So you have to think of words that go together. No and all are the same thing because it's saying the definition is everything. Because if I say all of these students or all of the students are wearing shoes, that means everybody in this class. If I say none of my students or no one in this class are wearing shoes, isn't saying no one or no the same thing as saying no one in this class? I'm counting everybody in this classroom. Just like all, I'm counting everybody in this classroom. So if I want to negate all coins have the image of George Washington, all means every single one. I can say to negate that, some coins. Because if I'm saying some, it's not definitive. So remember, all and no, or all and none, mean the same thing. It's counting everybody. It's counting everything. Some is counting just at least one person. So, compound statements, remember those are two or more simple statements. The connectives, often used to join two simple statements, are and, or, if then, and if and only if. Also, but, nevertheless, however, those are all connectives. Not statements, also known as negation. The symbol used in logic to show the negation of a statement is this right here. I forgot the name of it. This morning I was saying it to myself because I knew I had to record this video. And then, of course, I'm recording this video and I forgot the name of that little squiggly. If we want to say not, we're going to put that little squiggly. So if I want to say the negation of P or not P, we put a little squiggly P. And statements, also known as conjunctions, is this little symbol that kind of looks like an A. Thankfully, it kind of looks like an A. It's the symbol for a conjunction and is read and. So if I want to say the conjunction P and Q, I would put P, that little symbol, Q, which means P and Q. The other words that may be used to express a conjunction are but, however, and nevertheless. So all of these three words just mean and they just mean that little symbol that kind of looks like an A. So we're going to write the following conjunction in symbolic form. So we want to take this sentence that we're about to read and put it into symbols. So because we're talking about symbolic form, the symbols we usually use are P, Q, and R. Those are all lowercase. We don't go any further than R. You could use A, B, C. You can use any variable you want to use, but it's mostly used P, Q, and R. Just like in math, when you're solving for x, there's x and y. Same thing here, we use P, Q, and R. So P is your first statement, Q is your second statement, R is your third statement if you have it, and so on. When we write something into symbolic form, we always want to write the positive version. You always want to write the non-negated version of a sentence because you have to think of this. A simple statement doesn't have the word not in it. Saying not, that's not simple. If I want a simple statement, the sky is blue. Very simple, right? Nothing special about it. Boom, sky is blue. Cool. But if I want to write something else about it, I can say the sky is not blue. I'm taking it away from being simple and I'm negating that sentence. So that's why you always write the sentence before it was actually negated. So our P is the first thing in our sentence. Ocean Lab is on tour. Remember, we don't do that not. So that's our P. Then we have a comma, but, we'll get to that. Let's figure out our next simple statement. Ocean Lab is recording a new album. So that's our Q. Alright, now we're going to write this into symbols. But before we write this into symbols, the connective is the word but. So we know that our connective is but. So all that means is and. And all that means is this symbol right there. It looks like an A. Thankfully, it looks like an A. Something in math actually makes sense. Alright, so now we're going to go back to the sentence and write it using our symbols. So Ocean Lab is on tour, so that's P. But, which just means and, they are recording a new album, so that's Q. The only thing that we need to plug back in is this not right here, because it's saying not. So to say not, remember, we just use this little symbol, this little negation symbol. So we do not P. Because that's what we're saying. We're not on tour. So that's not P. And that is our final answer. This will come easier as we go along. That's why for 3.1 you kind of have a lot of homework because it's just a bunch of putting it into symbols. It's practicing. I promise you though, if anyone you know has taken this class, they can say this was one of their highest tested scores that they've had in the class. It's going to take a little bit to kind of get that ball rolling, but it will roll. I promise you, okay? Hang in there. Let's get to the next example. Another type of statement is or, also known as disjunction. So the disjunction is symbolized by a V and it is read or. In this class, the or will be inclusive, and it's always inclusive. It will never not be. It's inclusive. So you don't need to worry about what type of or we're working with. That comes later on if you're going to take 1107. So if you want to say the disjunction of P and Q, we say P, V, Q. I'm going to do example 3 up over here because I didn't leave myself space. All right, so we're going to write a disjunction. So it's giving us P is Camilla will take chemistry, Q is Camilla will take French. So let's write each sentence in symbolic. Camilla will take chemistry. So that represents our P. Then it gave us our Q as Camilla will take French. So as we read through the sentence, let's go ahead and underline the parts we're talking about. So Camilla will take chemistry, that's P. Or, that's our connective, Camilla will take French, that's Q. So if we wanted to break this down, Camilla will take chemistry, that's P. Or is the little V symbol. Camilla will take French, that represents Q. There's no negations in here, so that is our final answer for A. So you're looking for, for what I mean by negations, the word not, or something like that. I want you to, as you watch these videos, periodically pause, try examples on your own, and then come back to see if you did them right. And if not, that's okay. So what I want you to do, I highly encourage it, is that you pause the video, do part B, and then come back to see if we did it correctly together. Okay, you back? I hope you paused it. I want you to know it does feel like I'm talking like Dora the Explorer when I make these videos. It's very fun and interesting. Alright, so we have Camilla will not take chemistry. I don't care about that word not right now. Camilla's going to take chemistry. So Camilla will take chemistry, that is P. Or, so we have our little V symbol. Camilla will not take French. So Camilla will take French, that's Q. But we have to go back because we see these words not. Since we see the words not, we have to put the little negation symbol in front of P and Q. Because we're saying we're not going to take chemistry. We're not P. And then we're not going to take French, so we're not Q. Alrighty. When a compound statement contains more than one connective, a comma can be used to indicate which simple statements are to be grouped together. When we write the compound statement symbolically, the simple statement on the same side of the comma are grouped together within parentheses. So if we go back to example 3, you see how on each side we only have one statement on each side? Good to go. That's why there's no parentheses. But here we're going to have commas and a bunch of things, and let's see how that works with us. So going back to example 2, we have the comma here. But on each side of the comma, we only have one statement, so parentheses don't matter. If we go to example 4, when we start to read, see we have one simple statement, comma, then two statements, so we have to be careful. Alright, so P is dinner includes soup, Q is salad, and R is vegetable of the day. So let's write each statement in symbolic form. A. So, dinner includes soup, that's P. Salad is Q. And R is veggies. So let's read this. Dinner includes soup, P. Comma, and. So, and. Salad. Or veggie of the day. We need a parenthesis somewhere in here because we have a lot of things going on. And how do we know where to put our parenthesis? Let's look at that comma. See the comma there? That means everything to the left of the comma gets grouped together and everything of the right of the comma groups together. So we're going to group you could group the left, but since it's a single, just one statement, it's not compound, you don't have to group it together. But on the right side of the comma, we have two simple statements. That's why we need to group them together. Alrighty. Part B. Let's read this as we go along. Dinner includes soup, which is P, and salad. I always do that. You're going to write A when you do the and. Then we have or, veggie of the day. Okay, let's see if we have a comma in here. And we do. We do have a comma right here. So since we have a comma, everything to the left will be grouped, everything to the right will be grouped. So everything to the left will be grouped. We don't need to group the right because it's one statement, not multiple. And there we go. All right, now we're going to do the opposite. We're going to take statements that are given in symbols and we're going to write them using words. All right, it's telling us P is the house is for sale. Q is we can afford the house. So as we go along, we have P, so the house is for sale. Our connective is and. We have this little negation symbol, so we need to be careful. We have to negate the sentence, we can afford to buy the house. So to negate, we can afford to buy the house, we would say we cannot afford to buy the house. Alrighty. So B. I have negation P, so I need to negate the house is for sale. So I would say the house is not for sale. Then we have our connective of or. So the house is not for sale, or then we have negation Q. So we need to negate Q again, and we already did that. Is we say we cannot afford to buy the house. Alrighty, part C. This is where I highly encourage you stop, try it on your own, come back. I hope you know when you do come back, don't feel bad if you got this wrong. C is a trick question. Alright, C. We have negation whole thing. Negation whole thing. So before we even get to P and Q, we have to negate the whole thing. So you can say it is false, or neither, or it is not true. So when you have a negation outside of those parentheses, we say, in this case, neither. Since we have those parentheses, right, that means comma. So neither, comma P, which is the house is for sale. Our connective is and we have Q, we can afford to buy the house. Okay. So it was probably where we saw that negation to begin with. We didn't know what to do with it when you came back, but now you do. So whenever we have a negation in or outside parentheses, we need to negate the whole statement before we even start writing it. You're asking yourself, B and C mean the same thing. They are equivalent forms. We will talk about that in chapter 3. Just not yet. Let's not get about herself. But if you're like, B and C are the same thing, why couldn't I write it the same way? Because they're equivalent. They're not equal. They're equivalent. Meaning they mean the same thing. Like 2/4 and 1/2, they mean the same thing, but they're not the same thing. All right, throwing some more English at you. This is my extent of English class. If-then statements. The conditional is symbolized by an arrow and is read if then. The antecedent is the part of the statement that comes before the arrow. The consequent is the part that becomes part that follows the arrow. So the antecedent is the first part. The consequent is the second part. Because the antecedent is what you're waiting for, what you're anticipating for. The consequent is what happens afterwards. What's the consequent of your actions? So we're going to write conditional statements. We have P as The Portrait is Pastel, Q, The Portrait is by Beth Anderson. So we have our P and we have our Q. I'm pretty sure the phrase "mind your P's and Q's" comes somewhere from this. I just don't know where. But it's not our generation's phrase. It's an older generation phrase. All right, so we have if the portrait is pastel, so P, then. So you see how we say we have if then? That's how we know we have our if-then statement, our conditional statement, our single arrow statement. So we'll have P, then our if-then symbol. The Portrait is by Beth Anderson. So that's our Q. So we just said in symbols, if the portrait is pastel, then the portrait is by Beth Anderson. Alright, this is where I highly encourage you to pause your video, try B, and come back to it. So, be careful. If the portrait is by Beth Anderson, so that's if the portrait is by Beth Anderson, that's Q. We have our connective if then. The portrait is not pastel. So that's P, but since we have this little negation here, not, we have to put the little squiggly in front of P. Were you reading too fast for B? Did you actually accidentally put the wrong letter first? It happens. Slow down. Slowly as you read this. Colors help. Alright, so we have it is false that if the portrait is by Beth Anderson, then the portrait is pastel. So you see how we negated the whole statement before we even said P and Q or whatever? So that means we have negation, whole thing, because we negated. We already said before we talked about P and Q, we're saying it's false. So we have our connective of if then. So the portrait is by Beth Anderson, that is Q. Our connective of if then the portrait is pastel, so that's our P. All right, another type of statement is if and only if. That's called biconditional. So bi means two, and it's two ifs. That's why it's called biconditional. And it's double arrow. So double arrow, if and only if. Double goes with bi, goes with two. That's what's great about if and only if. It's easy to remember. So if we want to say if and only if, we would put double arrow. Okay, we're going to do the same thing we did in the previous example, except now with if and only if. So we're going to take symbols and move it to words. I don't want to write it. You can read it. Wrong one. There we go. Alright, so we have our P is Alex plays goalie on the lacrosse team. Q is the Huskies win the championship, and it's biconditional because we see double arrow. So biconditional means if and only if. If and only if can be abbreviated as IFF as well. So we have our P. So P is Alex plays goalie. So Alex plays goalie. Double arrow, if and only if. Q, the Huskies win the Champions Cup. And then for B, we have Q first. So Q represents the Huskies win the Champions Cup. Double arrow, so if and only if, IFF. Negation P, so we have to negate Alex plays goalie on the lacrosse team, so we can say Alex doesn't play goalie on the lacrosse team. And for C, we have negation outright. We have the negation before we get to P and Q, so we have to say it is false. Then we have P, Alex plays goalie on the lacrosse team. Double arrow, if and only if. Negation Q, so we have to say the Huskies didn't win the Champions Cup, or the Huskies don't win the Champions Cup. Luckily, every test is multiple choice, so you're not going to have to struggle with what word should I use. Should I say neither? Should I say it is not true? Should I write doesn't? Should I write cannot? What do I write? But it's multiple choice. All right, this little box here is literally everything we just went over on what the symbols mean, how do we write it in symbolic form, what the formal name is. This is something that you should have with you, so to be easier so you don't have to keep flipping back in your notes. Just have this page when you're doing your homework.